Hey guys, it's Rosato again. So last week we did asteroids and meteors. This week we only have comets, so it'll be a pretty short week. But comets, as you'll see, are probably the most spectacular of the three debris categories. So let's go ahead and jump into that. So here we have a typical image of a comet. A lot more interesting to look at than an asteroid, and longer lasting than a meteor. So comets in general are just icy, rocky objects that orbit the sun on very, very elliptical paths. Now, as they approach the sun, they get warmed up because clearly the sun is very hot. As they get close to the sun, they get warmer, and that ice starts to warm up. And as it warms up, it doesn't turn into water, it goes straight into a gas. And when that gas starts forming, the comet starts to take on the appearance that we're used to seeing. And these are believed to have been formed on the very outer edges of the solar system. Unlike asteroids, which are believed to have formed closer to the sun and similarly to how the planets did in the same disk, comets are believed to have kind of formed from the leftovers on the outsides. So here's a basic diagram of a comet. So you can see there's the sun, huge, very stretched out ellipse. You can see its tails as it goes around the sun. Notice I said tails. A comet doesn't just have one tail, it's got two. So we'll talk about the parts of a comet. So when it's far from the sun, it's just dirt. It's rock, ice, and dust. There's not a whole lot you're dealing with here. It's going to be almost indistinguishable at first glance from an asteroid. It's just a big rock with some ice on it. That's only when it's far from the sun, when it's not very interesting. Once it gets close to the sun, that's when it warms up and the ice sublimates. What that means is it goes from being solid straight to gas. There's no liquid in between. Ice, it would make very little sense if these comets, as they warmed up, suddenly became this ball of rock surrounded by like water, and the water then had to dissipate. What happens is it goes straight from ice to gas, similar to dry ice here on Earth. And it has four parts. It's got its nucleus, it has a coma, a dust tail, and an ion tail. Once again, notice two tails. So let's talk about each of these parts. The ion tail is caused by the solar wind. So remember, the sun is constantly giving off radiation. Just charged particles are constantly flying off the sun. The solar wind pushes that gas that's coming off the comet straight away. And it always points directly away from the sun. So the ion tail is very straight looking, and it's usually blue in color. So you'll be able to tell it apart from the dust tail. So the dust tail is, as it sounds, dust that's getting blown off of the comet. Now, it also points away from the sun too, but it tends to be curved. So the ion tail is very straight and blue looking. The dust tail tends to have more of a curve to it, and it's usually like white or yellow. So we can see here, the ion tail has much more definition to it. It's much straighter. It's very blue. And the dust tail is just kind of like a blob. As opposed to being pointing straight away from the sun, you get this blob shape to it. It's not as well defined, and it's very white looking. Now the coma is the gas. So it's like a bubble of gas that surrounds the nucleus of the comet. And the nucleus is, of course, the main rocky ice body that the comet is on the inside. So the rock ice part is the nucleus. It's covered by a bubble of the gas, which is called the coma, and then the tails are shooting off. Now we have a couple types of comets. They're defined by how they go around the sun. And it mostly comes down to, do they orbit quickly or do they orbit slowly? If they orbit quickly, we call them short period comets, meaning it takes them a short period of time to orbit the sun. And it's short in relative terms. These are comets with orbits less than 200 years. which of course sounds like a really long time to us. But remember, in space, time scales are much bigger. The whole solar system took, 4.5 billion years to form, and that's not that long. Then they orbit on the ecliptic plane, like the planets do. And these come from the Kuiper belt. Remember, our solar system, we have the sun, we have the planets, then we have the Kuiper belt, which is an area of ice, rocky bodies like Pluto's and such. And then outside of that, we have the Oort cloud, which is this big dome of comets that surrounds the solar system. So if the short period comets come from the Kuiper belt, you may figure out that the long period comets, which are the ones that take longer than 200 years, come from the Oort cloud. So the Oort cloud is that dome I was talking about, the really far out dome of comets that we believe surrounds the solar system. These are where comets that take a really long time to orbit the sun come from. They have random orbits, so they don't follow the ecliptic plane, the path of the sun nearly as well. They kind of do whatever they want. And they can take thousands of years to orbit the sun. So most comets are found in the Oort cloud. Like I mentioned, we believe it's a big dome of comets that surrounds the sun. And if you were to take all the comets and add them all up, they would have more mass than all the planets except Jupiter. So we have a lot of comets in our solar system. So here's the diagram. There's the sun in the very center. This like yellow-brown disk is the Kuiper belt, and outside of that, this big circle is the Oort cloud. So the Oort cloud is absolutely huge and very, very far away. Now, these comets that are in the Oort cloud, they would be content to just hang out in the Oort cloud and never head to the sun. But the thing is, there are gravitational disturbances that probably knock them out of their orbits. Things like other stars just happening to come too close to the solar system, and a comet suddenly gets swung towards the sun. So here you have on the left, the Oort cloud. A comet is just going around the Oort cloud, doing its thing, but then this star comes by. Well, as that star comes by, its gravity is going to influence everything around it, including these comets. And some of them are now going to start heading towards the sun, towards all the planets in the solar system. So basically, they've just been knocked out of what their original orbits were, and now they head towards the sun. Now, when they do that, sometimes they get close to Earth. When they get close to Earth, we can see them. So comets, we have seen them in the sky. There are some very famous comets. But also, they leave those trails behind. Remember those tails? Well, when they leave those trails behind them, sometimes the Earth goes through their trails. When the Earth does that, all of a sudden, all this little debris, the Earth is going to run into it, and all that debris is going to hit the Earth. Well, it's usually tiny pieces of rock that you may not notice. But sometimes there's a lot of it, and sometimes there's big chunks of it. And if it hits the Earth's atmosphere, it starts to heat up, and it falls to the Earth. And these are what cause meteor showers. So meteor showers, like the one I mentioned to you guys yesterday, the Eta Aquarid shower, are caused when the Earth passes through the tail of a comet. Now, all comets, eventually, the ones that are heading towards the sun, eventually they'll keep going to the sun. And every time they go to the sun, they get hot. And more ice goes away. And eventually, they don't have ice anymore. When they don't have any more ice, we call them extinct comets because they won't have tails anymore. Since they don't have a tail, they would be indistinguishable from an asteroid or a meteor. It's just a rock now. Now, there are famous comets. So we have Halley's Comet. This is probably the most famous comet. So Halley's Comet is named after Edmund Halley. It shows up about every 76 years or so. It should be coming back around 2060, I want to say. Let's check that real fast. Halley's Comet, yes, it will come back July 28th, 2061. So hopefully we'll all be around and be able to see Halley's Comet. And then we have Comet Hale-Bopp. So Comet Hale-Bopp showed up around 1997, I believe. And this comet is especially famous for not only being very impressive to see, but there was a cult known as the Heaven's Gate that believed a spaceship was hiding in the tail of this comet. And they believed that they could join these aliens in their spaceship if they all committed suicide when the comet approached. So 39 people committed suicide and hoping their spirits would join the spaceship following this comet. Needless to say, a spaceship was never detected near this comet, but this is what Comet Hale-Bopp is famous for, its beauty and that cult. And that's all I have to say about comets. So I will be posting a quiz over this stuff tomorrow, Wednesday. Of course, if you have questions, let me know. I'll be having office hours Thursday from probably 12 to 2. Pop in, ask a question if you have one. You can email me, post in Google Classroom, whatever it is. So in the meantime, watch the video, prepare for tomorrow's quiz. Be sure to like and subscribe, and I'll see you guys in the next one.